Hello, this is Group 25 and we'll be presenting on axial flow turbine. In this presentation, we are going to be looking at what axial flow turbines are, how they operate, the relationship it has with the first law of thermodynamics, and some advantages and disadvantages. What are axial flow turbines? A turbine is any device that extracts energy from a flowing fluid. An axial flow suggests that the fluid is flowing parallel to the plates and rotor of the turbine. Axial flow turbines are turbines that extract energy from a fluid that is flowing parallel through the turbine. They are known for producing high power outputs at relatively low pressure drops due to the high efficiency of the turbine. The operation of an axial flow turbine. A high pressure fluid, be it water, steam, or gas, enters the turbine at the nozzle. Here the fluid expands at the expense of the pressure, causing the kinetic energy of the fluid to increase. The stator blades then position the flow in for optimal energy extraction. The fluid then flows into the rotator blades or rotor blades, where it is further accelerated. The movement of the fluid through the blades causes the blades to spin, generating a torque and thereby spinning the shaft. The kinetic energy of the fluid is then transferred to the blades, becoming kinetic energy of the rotor and rotor blades. The energy generated here can be stored in a generator and converted into electricity or some other form for mechanical use. Relationship between the axial flow turbine and the first law of thermodynamics. The first law of thermodynamics states that energy can neither be created nor destroyed, but can be converted from one form to another. Similarly, in the operation of the axial flow turbine, a high pressure and high temperature fluid with significant thermal energy and kinetic energy enters the turbine. As the fluid flows, the kinetic energy in the turbine in the fluid is converted to kinetic rotational energy in the rotor blade, creating a torque which causes rotation and kinetic energy in the shaft. The energy of the shaft is then stored while the remaining energy leaves the turbine as exhaust. Then the total energy input, which is the kinetic energy of the fluid, should be equal to the energy of the shaft, the kinetic energy of the shaft, plus the remaining energy that leaves the turbine as exhaust fluids. Advantages and disadvantages of axial flow turbine. The axial flow turbine has high efficiency, compact design, and low maintenance. High efficiency in the sense that the efficiency of the axial flow turbine is about 95%. Its compact design allows it to be easily portable, and it requires low maintenance since it has little to no moving parts. However, the axial flow turbine has its disadvantages. The materials required for the construction of the axial flow turbine are very expensive because because low friction, corrosive resistant materials are required. It also has a complex design in order to minimize losses. And the speed of operation is high, causing wear and tear of the parts. Why turbines are important to engineers? It provides renewable energy. The energy source for turbines, water, wind, and gases are all renewable, and as a result, turbines are also capable of producing renewable energy. Turbines are also important to industrial processes in the use of pumps and compressors. Lastly, the axial flow turbine is reliable because of its continuity of operation.